Good day and welcome to the Math Salon. I'm Dr. Anumende and we are going to look at 3 paper 1 questions for the advanced levels. So our first question says, find the Cartesian equation of a plane with parametric equations x equal to t into t minus 5 and y equal to t plus 2 plus t. So yeah, the parametric equation means with our parameter here is t. It's a new parameter introduced to differentiate x and y variable, to split them. So if we were to do a Cartesian version, it is to eliminate the t so that my expressions are now in the form y and x without the t. So I have 2 equations. I can make t the subject of this and substitute in this, or t the subject in this and substitute in the other. This second equation looks easier, so I can easily make here t the subject and then substitute in that one. So y is equal to 2 plus t. That means if I take 2 to this side, y minus 2 is equal to t. X is equal to t into t minus 5. Now that I know that t is equal to y minus 2, I can substitute y minus 2 in all the places of t. So x will be equal to y minus 2, that is for this t, brackets, y minus 2 for this other t, and minus 5. And this is equal to minus 2 minus 5 is minus 7. So I have here y minus 2 times y minus 7. You open this up, y times y is y squared. Y times minus 7 is minus 7y. Minus 2 times y is minus 2y. Minus 2 times minus 7 is plus 14. So this ends up being just y squared minus 9y plus 14. X is equal to that. You can arrange everything comfortably or neatly onto the right side. If I take x this way, then it will simply be y squared minus x squared minus 9y plus 14 is equal to 0. And that is your Cartesian equation of the plane. The second question is, given that x is equal to 2 theta plus sine theta and y is equal to cos theta, find dy dx. Once again, notice that our x and y are split apart by a different parameter. This time is theta, and we are asked to look for the gradient or dy dx. Normally, our dy dx would have been simple if we had a function that was in terms of x and y, but this is not the case. So we have to apply, we had learned this before in some other videos, a chain rule. So which means I'll take dy dx and multiplied by d theta divided by d theta. That means multiplied by 1, and therefore that doesn't change. But then in order to make it neat, I take it to a salon and make the hair better. So that becomes dy d theta. I shift the hair close to the eye here and put the other that way. D theta dx. But I would have to differentiate my x with respect to theta, so d theta dx is not very handy. You could start trying to play around here. So the best one would be dy dx d theta, divided by dx d theta. This is division. So if I want to multiply, I will invert and I get exactly that. So what I'm left to do is look for dy dx and then dx d theta, dy d theta, and the x d theta, and I just substitute into this. So from here, let's take that of dy first. Dy d theta is just equal to minus sine theta. That's the derivative of cos theta. And for the dx d theta is equal to, if I differentiate with respect to theta, I get 2. That's just like 2x, the derivative of 2x is 2. I differentiate it with respect to theta, that is cos theta, plus cos theta. So if I want to get my dy dx from here, I will just substitute, that is minus sine theta divided by 2 plus cos theta. The third one says, find the value of p given that the curve y equal to px squared plus 12x minus 1 has a stationary point at x equal to 3. A function or a curve that has a stationary point when it's either a maximum or a minimum or a point of inflection The most important is that at that point the derivative is equal to 0. So if my is given as y is equal to px squared plus 12x minus 1, then my dy dx is equal to 2px plus 12, and this should be equal to 0 at the point when x is equal to 3. At x equal to 3, therefore that means 2p times 3 plus 12 is equal to 0. 3 times 2 is 6, so 6p plus 12 is equal to 0. That means 6p is equal to minus 12, and p is equal to minus 2. That means minus 12 divided by 6. If you liked our video, please do not forget to subscribe. That's free. Thank you.